Hi, we'll start today with the Arduino. I really wish to have this lecture in the class, but in order to have really a good coverage of all the material, I was obliged to start with this voice over PowerPoint. So the Arduino, as you can see, we're here we started in fact dealing with this digital control architecture, which I call generally the brain. We covered the sensors, we covered how we do signal conditioning to these sensors, and now this signal is digital. We remove noise, we remove the level, we amplified it, and then we digitize it, and is ready to go into the brain. Before entering into the Arduino, I want to have really a good introduction about microprocessors and microcontrollers in general. So it's a replacement for hardwire relays. We saw in our milestone, I think the first one, that really it was really difficult dealing with flip-flops, dealing with different logic gates. And consider that, for example, I have to remove one of these conditions or add another condition, you have to rewire everything. So the idea is here, let's code this in a software base and put it in a microcontroller. Now, in every change, I do not have to rewire. I will go into the software and change the code that need to be changed. What are the different kinds of brain that can be used in mechatronics systems? We have the microcontroller, which is the basic one. We have the DSP. The DSP is a microcontroller, but it has really a higher capacities in terms of mathematical functions. I can do Fourier transform very easily on DSP. I can do sine, cosine. I can do these typical things of really high level mathematical, which are in fact needed for video image processing. So it's not very used in mechatronics applications, simple robotics mechatronics applications, simple between brackets. Then we have the PLC, which we will be covered also in this course. The PLC is, in fact, it's a microcontroller inside, but it is made in a way to withstand rugged environment, industrial vibrations, these type of things. And you can have the PC and software. For example, I can use MATLAB, I can use LabVIEW in my PC and put a data acquisition card where I connect the sensor into my PC and I can read, do the code, and then output what it needs to be output. And as you can see, the advantage here is that the PC is always there. The disadvantage is that you need a PC. For example, for the microcontroller, I will program it, remove it from the PC, and put it in the robot, and the robot will go and run this program alone without a continuous connection to the PC or a laptop. So if I want really to go into the microcontroller, what's inside it? So first, you have the microprocessor, which is the heart of every microcontroller. This microprocessor, it has a very important part which is called the arithmetic logic unit. This is where all calculations are done. This is where the instructions are decoded. What do I mean by instructions? Are the code that I upload inside the microcontroller. These instructions are fed into the arithmetic logic unit, and this arithmetic logic unit, this ALU, will do the job of most things to be done. So this is really the heart of every microcontroller. Then if you add to this microprocessor some memory and some external input-output to the word, this is your microcomputer. So this is the computer that we have on every desktop. This is our laptop. So our laptop is a microprocessor plus some memory plus some external interface, يعني USB, serial, etc., etc. If we add to all of this some systems pertaining to timers, to analog to digital, digital to analog, communication with different types of protocols. So this is a microcontroller. So a microcontroller is a computer adding to the computer timers, A to D converter, PWM, and we will see adding to these, I will call them now components that can be useful for our specific applications. So I don't want to go into the history of microcontrollers, but really one of the things that got to this revolution of microcontrollers is the Motorola HCS-12. The Motorola HCS-12 is one of the, not basics, but it was done in 1993, 2000, in year 1999-2000, and it was manufactured by Motorola based on BMW Mercedes-Benz S600. So they wanted to have multiple connections, so the Motorola created this HCS-12, and it's quite expensive, $10 per microcontroller, but it has really so many modules that can be connected. Then we have, at the low expensive side, the microchip PIC. The PIC is a large family of microcontrollers, very useful in mechatronics application, since they are really very inexpensive. They have low pin count. What I mean by pin count is how many pins are available to be connected to the outside world. And small memory. So you can choose between, and now you can have multiple other microcontrollers. You have the Arduino, which is one of the, and we will see why the Arduino is now a very used microcontroller. So the microcontrollers can be what they call CISC, or they can be RISC, or DSP. What I mean by CISC is complex instruction set, and RISC is reduced instruction set computer. I won't go into details of all of this, but if I want to really in 2 words explain this, I can say that reduced instruction set computer is a microcontroller with a very limited number of instructions. However, the complex instruction set computer is a microcontroller with a very large number of instructions. Arduino is a CISC because it uses the C language, and the C language has so many instructions that can be used in the Arduino. So Arduino is CISC. Then another typical characteristic of a microcontroller is the size. And we see that, and we will know that the microcontroller has a certain place in memory. And this memory can be, we know that all brains work on digital, 0 or 1. So these memory size is important. So the memory size is 8-bit, 16, or 32. You know from your Windows that some of the Windows come in 16-bit, some in 32-bit, and all of these are how much memory we are using, size of the memory, not how much memory, sorry, the size of the memory. So each line of the memory, is it 8, is it 16, is it 32? And we have a very large number of lines of these memory. Arduino is an 8-bit microcontroller. Here you see really the table where you have general purpose, embedded control, DSP. So we are here, we are at a general purpose, complex instruction, and 8, which is not in fact here. Okay? How can I program microcontrollers? So there are so many different types of languages in a microcontroller. Why? Because in fact the microcontroller, as I told you, will understand only zeros and ones. So I will put a assembler beside it. This assembler will transform what we call an assembly language to 0 and 1. So the assembly language, which is shown here in the first line, is the basic programming language of all microcontrollers. And from this assembler, I can I can convert this assembly language into 0 and 1 code to be understood by the instruction decoder and the ALU. But the problem in assembly is that it is not difficult, but it's not very easy language. It has very basic instructions. So really, if I want to do a sign, I will have to find the Taylor series of the sign in order to have addition, division, and multiplication to do all of this, because the assembly has only divide, plus, multiply, and add. So it's really very hard to work on assembly language. So what they created is they created what we call a compiler that will compile any language to assembly. So I can create now a language called MEN401, a compiler for this language, and I can create a code in MEN401 language, and the compiler will transform it into assembly. So this is why we see many languages that can be used in microcontrollers, and we see many manufacturers that manufacture microcontrollers, they have their own language. Example, PIC Basic for PIC, MPLAB for microchip controller. Arduino is a language also. So Arduino is a language as well as a hardware, as a microcontroller. In Arduino, I use the Arduino language, which is very, very close to C. Through a compiler, this Arduino language will be transformed into assembly, and with the assembler, this assembly will be transformed into 0 and 1 and fed into the microcontroller. So what are the memory types of inside the microcontroller? There is what we call the ROM, read-only memory. So the read-only memory is a non-volatile memory. What I mean by non-volatile is when I remove the plug, the power plug, okay, from the microcontroller, everything will remain on the memory. So the data will be there even if the power is removed. So basically you think about it as, okay, it's a very nice place where I can put my program instructions. So I can put my program instructions there. So even if power is removed, then and power is put again, the program will run again because the program will be in the ROM. The problem in the ROM is that I cannot, as a user, program the ROM. I can call my Motorola, for example, and told them, I will send you by email a program, please put it on the ROM, and I want 1 unit of this. They will close the phone without even answering. Because it's 1 unit, it's nothing. They will not manufacture a ROM instruction with just 1 unit. However, if Mercedes-Benz, for example, calls Motorola and they want 10 million units of this with the program, they will do it for them. So the ROM is there in order to have basic boot instruction, basic instructions, but as users, as simple users, we cannot put our program instructions there. RAM, we will see where we will put it. RAM is random access memory. It's a volatile memory, so when power is removed, every data that is in the RAM will be also removed. It's faster than ROM. Faster, I mean by faster in terms of communication. Can withstand more access cycles. Is cheaper. There is what we call dynamic and static. I will not get into details of these two differences. But random access memory is suitable for what? It's suitable for temporary variable. So for example, I am reading temperature now, and I want to put temperature in a place, then I want to check temperature 5-6 instructions later, or 3-5 seconds later, or I am doing an average of velocities, and every 1 second I am finding the 1 microsecond I'm finding the velocity. This velocity will be put in the RAM. Every 20 reading I'm doing the average. So these are temporary variables they can put into the RAM, and this is the RAM that we will be using, in fact, to put all our temporary variables or our current variables that we will be using throughout our program. EEPROM. It's a erasable programmable ROM. So we cannot put our code inside ROM. We can put our code inside the erasable programmable ROM. So it's a non-volatile, it's typical to the ROM, but the thing is that when I want to erase what's on it, I will put it under UV. So this is why some of the microcontrollers, basically old microcontrollers, you see a part of glass in order to put under the UV, and the UV will have to erase the ROM, and then I will reprogram the ROM. It's nice, I can program it, I can put my instructions there, but it's not something very practical to do this. So this is why it was not very used, and now I think it's not used anymore. What is used is what we call the electrical erasable programmable ROM. So it's a ROM that can be programmed, non-volatile, it can be erased electrically. So this is the best thing. So I will send, for example, a 5 on one pin, and this 5 will erase the EEPROM. Then when I will put 0, I will be able to write on this EEPROM. And now, if power is removed, the EEPROM, the instructions will stay on the EEPROM. So now the EEPROM is a very crucial part of every memory, okay, inside the microcontroller. The flash memory, you can think about it as EEPROM, but it's very close to the ALU in terms of physically close. So the connection will be really, the communication will be very fast, and quick, and this is very important for different applications. If there are flash, it's nice to put our code in flash. It will be faster to see, and the flash is also electrically erasable. But generally the flash is limited because it's much more expensive than EEPROM. Looking at the Arduino. So the Arduino is an Italian brand. It's not a brand because it's an open source. You can go into arduino.cc and you can see that all the details of every Arduino microcontroller is there. So this is why you see Arduino made in China, Arduino made in everywhere. So the Italian guys wanted to do this in order to have really a very large community, to get some input of different persons in order to enhance. So this Arduino family has more than, now it's becoming, I think, around 12 microcontrollers. They are not creating the wheel. Why? Because the Arduino is based on microcontrollers already made by other manufacturers. Yani, take for example the Arduino Uno. The processor is ATmega. ATmega is a American company that manufactured microcontrollers. But they put this microcontroller beside some other modules to make an Arduino, and they sell an Arduino. So you have multiple Arduinos. Basically, most of them are based on ATmega microprocessor. But what is different is that you see different operating voltages. You see different analog. We'll see what's the difference. Let's take, for example, the Uno. The Uno, it has 6 analog input. Due has 12 analog input. Okay, has 14 digital input output. 6 of them can output pulse width modulated signal. However, the Due has 54 input output and 12 that can output a PWM. So it depends on the size, it depends on the specifications. We will be using basically the Arduino Uno. So if I want to really look into this, the speed of it is 16 megahertz. This is the speed of the CPU. How many arithmetic operations per second. So here it can do 16 million arithmetic operations per second. It has an operating voltage of 5 volt, and I will input 7 to 12 volt to it. It has 6 analog input. So here we see that we have an analog to digital converter inside the microcontroller. لأنه I will input an analog signal, inside it will be converted into digital. But however, the Arduino Uno does not have a digital to analog converter in order to be able to output an analog input. So there is no analog output for it. 1 kilobyte of EEPROM, 2 kilobyte of static RAM, and 32 kilobyte of flash. This is where I will put my program, and you have to make sure that your program is not larger than 32 kilobytes. So what I can say also here is a very important point that I will reiterate it after, is that the DC current per input-output pin is 40 milliampere. So I will not be able to output nor input to a digital pin more than 40 milliamp. You know that a digital pin, the output of it is either 5 volt or 0 volt, so either high or low, and the input is either high or low. But the amount of current, it cannot go beyond 40 milliamp, or else the pin will be not operating anymore. Okay, بيحترق. And maybe if the current is so high, the microcontroller will not be operational anymore. So this is why it's something very important. Generally, basic, when we first use these microcontrollers as beginners, we will have these type of things, because even if you do not design to have a current larger than 40 milliamp, a very small short circuit, okay, will create a very high voltage. Okay, so يعني إذا بالغلط we put something, and for example the 5 volt touches the ground, this is a short circuit, and a very high current will pass that will make the pin inoperational. So I will not also go into details of this, but what is important to see is that this is the 80 mega. This is the microprocessor, or the microcontroller, excuse me, that is the heart of the Arduino. As you can see, it has a CPU, okay, which is central processing unit. We will go and zoom into the CPU next slide. It has a flash, very close to it. It has a static RAM. It has an EEPROM. It has a timer. This is timer counter, TC, 8-bit timer, and we will have hopefully the time to cover this. It has an A to D converter, which take the analog input from here, and analog to digital converter, converted into digital and fed into the main bus. We have clock generators, 16 mega, in order to generate the 16 megahertz, which is the clock, and I have ports. What do I mean by ports? These are digital output or input ports. Yani these are the legs that you see at the output. These are the pins that you see on the microcontroller. If we zoom into the CPU, we see the arithmetic logic unit that is here. We see the memory. We see some registers, and we will talk about registers later on, and I will not go into details of all of this others. Here it's for the instruction, basically to decode the instruction and convert it into zeros and ones. What I mean by registers, the registers are lines in memory, but these lines are specifically for the CPU or for the microcontroller to be used. In other terms, if I want to use, for example, a PWM, they will tell you, please put a 1 inside this line of memory and on this bit. When I put 1 on this bit, PWM will go on. Because there is no other way to communicate with microcontroller except with zeros and ones. Okay, how can I tell the microcontroller that I want to use the timer? There is a bit specific for the timer. When this bit is 1, the timer will start. So this is what I call by, or what we mean here by registers. So there are storage locations within the CPU faster than memory, used to hold data and memory addresses during execution of an instruction. Accumulate results of arithmetic logic unit. Let's remove the accumulating now, but it's a way of communication. Arithmetic logic unit, this is, I explained, it's a circuitry that performs numerical calculation and logic functions. Sequence controller is a state machine that decodes program instructions and controls the execution of the instruction. It's very important for the instructions to be executed one after the other. Who will control this? It's the sequence controller. For example, I will give an example of a status register. The status register is a register, as you can see. This is a place in memory, by the way, and in fact, this is what we will see always when we talk about register or places in memory, is that first this is the name of the register, okay? Status register, SREG. And this name corresponds to a place in memory. This is the place in memory. 0x, it means hexadecimal, and it's 3F. The places in memory are coded as zeros and ones. But for us, zeros and ones are really unreadable when we are at 16 or 32-bit or larger. So here we put in hexadecimal part. So 3F is the location on memory. And this is the bit number from 0 to 7. Read-write is that can we read this bit or can we write on this bit? Most bits are read-write. It means that I can read from it what is the status, 0 or 1, or I can write on it. And the last line is the initial value. It is zeros here. It's the value out of reset. Yani when I reset my microcontroller, what are the values of this specific register? Here they are zeros. I will not go over all of them. For example, let me take the bit number 1. It's called the Z bit. So even the bit can be named. The Z bit, so it is the bit number 1 in the status register. This Z bit will be set to 1 if the last operation in the arithmetic logic unit has a result of 0. Yani, if I put 3 minus 3 and my result is 0, after this operation is performed, the Z bit will be equal to 1. And similarly, if I am doing, for example, addition of 2 words, and the addition has a carry or a borrow if it's subtraction, so if the addition produces a carry, the C here bit will be set to 1, etc., etc. And this is the cases. So for example, if I have a number, if an operation will output a number with the most significant bit equal to 1, it can be understood as negative, so the N bit will be set to 1. It's up to you. Maybe I don't want to use it as negative, so I will put this N bit aside and I will not look at it. If I am using the 2's complement, for example, I will check the N if it is negative or not, if my output is negative or not. So this is just an example on how registers work. Don't worry. Hopefully, fortunately, the Arduino will stay not so deep into registers. Will stay really at high level programming. Okay, we will go deep a little bit at the end of final 2 lectures or final 1 lecture on Arduino. But basically, most Arduino applications that we will use, we will not go into these details. But it's important that these details be understood in order to understand how we deal with microcontroller. لأنه maybe in your work you will work with other than Arduino, so you have to understand how most microcontrollers work. What we see here is what we call a memory map. A memory map of the Atmel or the Arduino. This is it. So in fact, it has a 2 kilobyte static RAM, 1 kilobyte fixed EEPROM, and 32 kilobyte of flash memory. Each line can be represented with 4 hexadecimal digits, 00000001F. So from 0000 to 001F, there are 32 registers, these registers that are used in order to program the microcontrollers. Okay, like the register we saw, which was the status register. Then we have from 20 to 5F, 64 input-output registers. These I cannot write, nor I can read from them or write, depending if these are input-output. So these are the pins. So these registers are each bit of this register is connected to a pin. If the bit is 0, the output of the pin is 0 volt. If the bit is 1, the output of the pin is 5 volts. Okay, then we have the external input-output registers. I will explain this a little bit after. And then we have the internal static RAM. This is where the temporary variables will be put. This is the Arduino Uno. Okay, so say hi to this guy, which we will work with it in our final project and in our milestone. So in this Arduino, what you see is the connections here. Okay, first you have here 7 to 12 volts, so this is the VIN that you will put to your Arduino Uno. This is the USB connection to your laptop in order to upload the program to it. There is a reset button. Okay, this reset button will reset if, for example, the program will went into infinite loop, or I want to reset it to do any other testing. This is the reset pin. Then we see here we have 14 from 0 to 13 digital input output, and 6 of them can output PWM, which are in tilde connection. Tilde here. So tilde 3, 5, 6, 9, 10, and 11. These 6 pin can output PWM. If you want to, you can program them to output PWM with a certain duty cycle, and you will see that the frequency can be changed also. Then we have the 0 and 1. These are for the serial communication. These are digital input-output عادي pins, or they can also used as serial connection to receive RX or to transmit TX. Then we have here analog inputs, 6 analog inputs. We saw in the list that the Arduino Uno does not have analog output. It has only analog input. And here you can see you can see the power. Okay, so I can put VIN from this adapter side, or I can put VIN from this VIN here. This is ground, it's important. 5 volt, this is not an input, this is an output. And 3.3 is an output. So here, if I really want to have a connection to the outside world exactly 5 volt, I will use this. But pay attention that I cannot go above 40 milliamp for this and 50 milliamp for 3.3 volt. Yani I cannot get this 5 volt and work with a motor, with a DC motor, with this 5 volt. This 5 is only used, for example, if I want to connect to the Arduino a shield. What I called by shield, there are multiple shields, and this is the force or the advantage of the Arduino, is that you have shields. Yani if I want to use Wi-Fi with Arduino, I will buy a Wi-Fi shield. If I want to use Bluetooth with Arduino, I will buy a Bluetooth shield. If I want to use a LCD, liquid crystal display, with Arduino, I will buy an LCD shield. Okay, and this shield will be put on the Arduino, and they will be powered by these 5 and 3.3 volts here. A very important point is that do not exceed 40 milliamp, and this is something very important. So this is a schematic. As I told you, is that nothing is hidden. The Arduino is open source, so I can buy the Atmel 80 mega 16, etc. I can buy all of these and connect the connections that we have, and I can create my own Arduino. Okay, I will not put I will put this is an explanation of Atmel and Arduino relation, so I will not cover this slide. I always remind my students, especially the beginners, is of this. This is a very important warning in order not to have all your money wasted on different Arduino boards. How can I install Arduino? I will go into arduino.cc and download the software. Okay, I will give you some hints on later slides. The first thing to do is to set what is the board that I am using. So tools, when you install this, you put tools, board, Arduino, and which is one of these you will be using. So we will be using the Arduino Uno. You will understand more why we need to specify the board, because when you upload the program on the board, the Arduino software should know which board that you are using in order to put the right program in the right register. Then you have to specify on which serial port you are connecting the Arduino. In our case, we are connecting it through USB, but you have multiple USBs in your laptop or PCs, so you have to specify on which USB you are connecting the Arduino. Okay, and in this here, I will stop here, in fact, on this slide, before entering into really the software side. So the software, every Arduino program is called a sketch, and every sketch is divided into two big parts, or two big functions, what I call the void setup function and the void loop function. So as you can see, it's called a sketch. This is the program. The void setup, this is where you place your initialization code. So in fact, this function is only run one time at the beginning of the program. Okay, if I want, for example, to turn on my A to D, to turn on my timer counter, to program in a good way some of the registers, once I will put them here. The void loop this is where the main instructions are, and this is a continuous program. So I will start with the first code, second code, third code, when it finishes, it goes back to the first code, etc. So it goes in a loop until the board is switched off or the reset. I hope that this is clear, because here I really introduced the Arduino, and in our next set of slides I will start with the Arduino software and how can I program the Arduino.